Thank y'all for joining us today. We're going to cover a lot of ground and a lot of information, and I really appreciate y'all being with us. And at the end, we're going to open it up for a lot of open questions. My name is Joe Bunton. I'm the Business Development Manager for New Millennium Building Systems. And yes, I do speak Southern. So, a little nominal fee, I'll give you some translations later. This is an educational program. This program today will come with 1 AIA or 1 PDH hours of credit. I'm not going to read every line. You can read as well as I can, probably better. If I start reading, you're going to fall asleep on me. But I am going to try to hit the high spots. I'm going to try to tell you the things that I think that are really point them out to you that you need to know. Understanding RFIs on this projects are now, they're very hard to get the answers back from the engineers. BIM is a great tool. BIM helps us get the drawings out and gets things where they all line up and work better together. We're going to talk about all of these projects, all these things during our learning. These are our chapters. Chapter 1, the cost of incomplete drawings. 2, the value of early design collaboration. 3, composite methods of design. 4, BIM-based joist and deck design. 5, in close today, we will try to go over some frequently asked questions that we have learned or gotten in our various seminars we've done. Joist and deck. A lot of your buildings have steel joist and metal deck on them. They're one of the first things that hit the ground. These are the things that go up first. When these start going up, that's when the RFIs start. That's when questions come in. That's when people start asking all of these, where does this go? Where does that go? What ties to this? We have found that approximately 40% of the drawings that hit the market nowadays are not 100% complete. I've been in the steel business a long time. Back in the 70s, when we would get a set of drawings, they would be 100%. You could build from those drawings. Over the years, the owners have learned to push. The owners have pushed the engineers and the architects to the point to get them out fast. Time is money. Drawings hit the street with a lot of questions to be asked. Therefore, we have 40% of the drawings hitting the street that are not 100%. Missing dimensions, missing load requirements. This is just a few of the different things that happen whenever we see the drawings that hit the street. Here's an example of a wind loads table that is very obscure. It doesn't give exactly what you're looking for. It doesn't tell everything you need to know. This is not clear. The steel joist coming in here, we don't know whether these loads, these snowdrift loads and all, are included in the weights. It's not clear. It appears that they're there, but you just don't know. It's an RFI. It's a request for information that has to go out and has to be asked. On this particular one, he was very clear. He told that the snowdrift, that the loads were included in the drawings, that the design includes these loads. So therefore, you don't have to ask these questions. That's the type of information that we need when we estimate and design and build these jobs. The supplier, he'll ask the fabricator. The fabricator will ask the contractor, and the engineer will ask the architect. And this vicious circle of RFIs, if it comes back around and we don't get the answers we need, we just put our head down and pray they're correct. In this, I'm going to try to show you how to cut out on the clashes, how to stop the reworks, the project delays, back charges, contingencies, and loss of income from not getting into your building soon enough. We're going to also try to show you how to hammer down the material. This starts a chain reaction. If we can hammer down the material, that means less warehousing, manufacturing, trucking, staging, and erection. As I've told you, I've been in the steel business a long time. The steel erector, the first thing he's going to ask is how many tons are there? How many pieces? How many tons of joist? How many pieces? How many squares of deck? What types of deck? And whenever he does this, he figures his price from that. So if there's less pieces and less tons, that makes his price less. The value of design collaboration. This is very important. We're going to talk about reducing the tonnage. That's what I just spoke about, the chain reaction. We're going to reduce the tonnage. The MSR clashes, design, metal decking. If I can show you how to take 13 cents a square foot out of your building, that don't sound like a lot of money, but 13 cents turns out over 500,000 or 1,000,000 square foot. That turns out to be some money. That turns out something you can put somewhere else. Maximizing your steel joist span, the span of the deck over the joist. 22 gauge metal deck will span 8'7" on a triple span. Now we see steel joist and deck on drawings every day that are 4 foot and 5 foot spacing. Even if we only move the joist 6 foot or 6'6", that's a lot more than 4 or 5 foot. So what you do is you cut down on your number of pieces and tons. For example, this particular project had 30K10 bar joist at 5 foot on center. Metal deck was 22 gauge, and we were looking for a 23 PSF dead load and a 32 live load. With just a little bit of time, we moved the bar joist 6'8". We went with a 32 LHO8. Now, I realize that a 30K10 is 30 inches deep and a 32 LHO8 is 32 inches deep. You lost 2 inches. Not really. A 30K10, the seat on it is 2.5 inches deep. A 32 LHO8 is 5 inches. So the top of steel actually went up 2.5 inches. Your bottom of steel went up 1/2 inch. But look at this. Just by moving them to 6'8", we stayed with the dead load and the live load as originally designed. We dropped 12.2% of the weight out of this project just by that one change. We were able to stay with the 22 gauge metal deck. The erector dropped his price 22%. Less materials, less tons, save money. Materials on this project, this was a $1.3 million steel package on this one. We were able to help save 9.7%. This is the original drawings. You don't see a lot of steel projects now that are square-cornered buildings. They all have funky edges and round ports. But this one was one of them. We are looking at 44 LHOH and 30K11 bar joist end to end. Now I just told you that an LH has a 5-inch deep seat and a K has a 2.5. But when they're end to end like this, everything gets a 5-inch deep seat so that your top of steel is level. 22 gauge metal deck, and he had them spaced at 5 foot on center. Just by we stayed with the 22, your 44s dropped to 40. We saved 4 inches right there. The 30-inch joist stayed the same. We went with what's called a total load over live load, and we moved the joist to 5'11 1/4. Now that don't sound like a lot. We only moved the joist 11 1/4 inches. Just that simple change took out 78.54 tons. 4 truckloads of steel. 270 pieces were removed from this project. Very simple, easy to do. Saved 9.7% on the money. This project was a huge warehouse. The engineer started out with 30 K-bar joist, dead load over live load. Bar joist girders were 44s and 32 inches deep. But coming in and helping redesign the loads on the joist and the girders, deepen up the girders, well, as soon as you start getting deeper, the first thing you think of is that price just went up. Actually, on this particular job, they took out almost 100 tons, 99.96 tons, 5 truckloads of steel that didn't go down the highway, that didn't have to be handled, that did not have to be processed. Saved 7.4% just in weight alone by making a few changes. There are good ideas out there, and there's ways to keep it down. Mechanical, electrical, whenever you have ductwork and things passing through the openings of the steel joist, and we ask where these dimensions are, the reason is they're trying to keep from hitting the bridging. They don't want to hit one of the verticals or one of the web members. If you hit that member and you've got another piece over there you're tying to and you have to move, then the piece that ties them together is now either long or short. You've got downtime, back charges, delays in your project. By knowing where these members come through, we're able to put the proper supports in there for weight. We're able to pass through without any problem, without any interference. Just move it over. Find out. These are RFIs that are asked. Now I realize that the mechanical, electrical guy usually will tell you that I'm the last man on the job. I won't be there for 6 months after you're done and gone. Just put it in there, I'll make it work. Well, that's great till somebody sends you a $6,300 back charge. Now, that don't sound like a lot of money on $1 million, $2 million job, but somebody's going to want to get paid. Somebody's going to want their money. So think about answering the RFIs, getting the questions answered. It cuts down on all of the fussing and back charges later. We were talking about the depth of bar joist seats a while ago, and I say bar joist, I realize that's an older term. They're steel joist. But whenever you talk about the seats on a 2.5-inch K-series joist, deeper, whenever you've got a long top cord extension, for this particular thing, we're going to use 5 foot. This joist is extending out over this for 5 foot. Well, that's normally a balcony. There's something out here. There's a handrail. There's concrete. Whatever. We're loading this up. Once we load this thing, think about changing it to 5 inches deep. Now, the other end of the joist can be 2.5, and all the joist in the field can be 2.5. Just this end that's sitting on this beam is 5 inches, and it has to be done early on because the beam has to drop 2.5 inches to make the top of steel level. But by doing this and putting our load out here, and for this example we're going to use 291 pounds out there on the end of this 5 foot long extension. At 2.5 inches, the angle size would have been 2 by 2 by 3/16. Top cord. Now, top cord means from one end of that joist to the other. It doesn't mean just the 5 foot or whatever. The bearing angle is 5 foot plus back to the first panel point. Now, going with 5 inches, I dropped it to 1.5 inches, 1/8 angle size. I saved 40% per bar joist. That adds up. That makes savings. Now you've got one of these or two of these. It's not worth dropping your beam. Stay with the 2.5, work with it. But this is ideas of way to remove tonnage out of your jobs. KCS bar joist. Man, joist suppliers love these heavy bad boys. A 24 KCS4, 40 foot long, weighs 660 pounds each. Now I realize that you can put a 2,000-pound load anywhere along that top cord. But if you know that that load is at 10 foot, 7 foot 3 3/8 or whatever, you can make a specialty joist out of it, indicate the load, you just saved 36% per bar joist. Now that's a lot of savings when you have a lot of loads like this, AC units, whatever. My little mechanical guy says it's about 10 foot. Well, that'll jump up and bite you. There's a product called load zone joist. Now, this gives you options. It gives you ways to work. All joist manufacturers build them. Zone A, we're looking at 1,000 pounds, anywhere from 2 foot to 12 foot. I can move it around. I can go from anywhere within that 10-foot range. I'm not dead point located. I have another 2,000 pounds, anywhere from 10 foot to 17 foot. I got 7 foot. I can move that 2,000 pounds around. I'm still 21% lighter than a KCS bar joist. Savings is what we're looking for. And this is another way to do it. It's very simple. Go to any SJI catalog and it will give you the way to put this on the drawings where all SJI manufacturers can build it. End moments. A lot of times when we see a steel end moment, first thing I'd like to do is like to put steel beams in there. That way you can transfer the load into the column or whatever. Well, with steel bar joist, with a transfer plate and a stabilizer plate on the bottom cord, full pin weld at the top, you can now transfer the load, whether it be 4 kip, 5 kip, 6 kip, whatever, from that steel joist out to that column and down. Now you have the openings. You can run your mechanical, your electrical, your duct work through there. If you put a steel beam in there, you've either got to put a panel to run through or you have to lose head height by running under. Steel joist gives you options: faster, easier, cheaper erection. This is a project that was done in South Carolina. This was the School of Science and Math. Now, the original design on this project was a nice big gable joist. This joist was made into 2 pieces, a top cone and the bottom. Once the engineering got into it, they realized that this thing was so top heavy that it could not be put together on the ground and raised up and put in the air in one piece. The bottom half was going to have to be put in and bridging installed. Then the top cone would have to come back and be set at a later date. With a little bit of thought and a little bit of engineering, they came up with this truss on the bottom. It's called a Fink, F-I-N-K truss. The Fink truss, this is a School of Science and Math. It looks a lot better anyway. It's made in 3 pieces, left, right, and double angles tying the bottom together. Just in this little bit of change and making it look better, we had 50% less material. Look at how many less little bitty pieces they are to put in. How many less little bitty pieces they are to weld, to paint. Manufacturing dropped 20%. Freight dropped 60%. Handling dropped. Storage, erection, there's that chain reaction we talked about. The erection, he dropped his price 60% because he didn't have to go back and set a second set of trusses. There are good ideas out there and there's great ways to save money. Metal deck gauges, all different types of metal deck are manufactured, from B deck, F deck, form deck, sail, cellular acoustical, composite decks, end decks. But there's also, you run into that gray area. I'm looking at 9'3". Well, 22 gauge will only go 8'7" in a triple span. You're also able to get what's called half-size decks. Now, first thing I'll tell you is don't try this on a 7-Eleven. It takes time and takes money for a mill to resize. So when you have a project, approximately 500,000 square foot is about your rule of thumb. Look at changing, instead of a 20 gauge, go to a 21 gauge. Now, engineers will look at it, they can work it out for you. SDI, deck, Steel Deck Institute, engineers, any of these guys will be able to tell you whether this will or will not work for your project. But we just took out 40 tons on that 500,000 square foot job right there. 2 truckloads of deck that didn't go down the highway. $25,000. Now this has to be done early on because there are some times that have for them to revamp the mill. It takes about 2 weeks to get it all done, and it has to be enough coils to pay for all that extra time. Deck gauges. This project right here was a 600,000 square foot project. They originally started out with 22 gauge metal deck. Once they came back and changed it to 23 with a 25 PSF gravity load, the joists were spaced at 5'6" and 5'8". Patterns, the side lap patterns changed for the interior from 5 to 8 and from the edges from 7 to 10. They saved 8% on that project just in deck alone, just by that one change. Doesn't cost any more. Side laps are cheap, very cheap. There are options. There are things to make you think. There are things you can work with. But when you're designing and you're coming up with your deck gauge, be very careful. Watch out for these openings. This particular opening right here is close to the edge. So I've got a single span and I have some double spans. So if I said that there was 20 gauge over that entire job, my estimator estimated it as 20 gauge, and then they get to engineering and they say, by the way, this right here is going to be 18 gauge because it's single span. It's not going to span that far. Therefore, you're going to end up with a back charge, or you're going to end up with an extra. You're going to end up with somebody wanting more money. So watch out. Don't get caught in this little trap. Shoring is another expensive item. Don't overspan the metal deck. If it says 8'7", don't go 8'8" or 8'9". Shoring is very expensive. Now, there are metal decks that have to be shored. They span long distances, but those are understood and that's built in. These type decks, your standard common B decks, N decks, form decks, don't overspan them. Finishes. G60 will galvanizing is A653, painted means A1008. G60 and G90, that's your standard normal glacier for galvanizing. Basic painting to galvanizing G60 is $14.50 per square, or $14.50 per 100 square feet. But if I can do with 60 and I don't need 90, why pay that extra $6 per 100 square foot? If you can use 60, say 60. Don't leave it to the imagination of someone and come back later and find out you could have saved money. Deck accessories. Metal deck accessories is one of those items that we find all the time not being put on the drawings. Whether it's valley plates, edge closure, pour stop, whatever. Put it on there. Tell us what you want. Do not leave it to our imagination. My wife tells me all the time, I'm not a mind reader. And she's right. This guy was very plain. I put a 14 gauge pour stop on there. No problem. We picked it up. It was right there. Everything he wanted. Here he wants a 3/16 bent plate. The structural guy got that. But he was very plain. He told us what he wanted. SDI manuals give you all of the deck accessories, what lengths they come in, where they're formed, everything you need to know about them. Tells you that they come in links, gauges, galvanizations, whatever. Gives you the information you need. When we were talking about deck a while ago and RFIs, one of the main things that we find all the time is edge of deck and edge of slab, not put on the drawings. Well, the reason for this question is all metal decks don't lap. B deck, you can lap it on top of another piece of B deck. It don't matter if it's 20 foot. It'll back up. It's no problem. Form decks, they are fine. But you have a lot of decks like composite decks, specialty decks, dovetail decks, sail decks, cellular acoustical decks. Things of this nature will not lap. They butt end to end. So this dimension to the end of this metal decking or to the end, giving them some way to find out exact what the deck length has to be. That's what we're looking for. We're not looking for this just for fun. This is why we have to have it. All decks do not lap. Composite, we're going to talk about composite deck, composite joist, and composite floor systems. Standard commodity composite metal decks come in 1.5 inch, 2 inch, and 3 inch. But you also can get composite bar joist. A steel joist can be made into a composite where the top cord is thicker so that you can shoot the studs down through the metal decking onto the top cord. The bottom cord is heavier for the composite action. You have to know the dead load, live load, and composite load to design for composite bar joist. But once you use composite joist, instead of steel beams, now you can run your ductwork, your mechanical, your electrical, everything through the openings. Faster, easier, cheaper erection. If that was a steel beam, I'd have to have openings there for all of this stuff to go through, or I'd have to drop down underneath, and I lose head height. So this gives you options versus steel beams. Especially composite decks, dovetails, deep rib decks. The dovetail decks come in 2 and 3.5 inches deep. You see that they have a lot of different, you can see the bottoms of them. They give you a lot of different things. You can hang stuff from the bottom. This is a job that was done with the thinner slabs, not having to use the deeper decks. Look at how far they span. You're able to cut down on the steel that's required, 40% less concrete used. Goes down fast and easy. The 2-inch dovetail deck can either have normal weight, lightweight concrete. These are your fire ratings, UL, and composite dovetail acoustical, 1 to 3 hours. 3.5 inch dovetail, again, 1.5 to 3 hours. 3.5 inch acoustical composite. Dovetail composite acoustical. Still, note that they're offset here. They're not butt end to end. The reason is for if there's smoke or fire in one room, it gets up in that little vent. You don't want it to get over into the other room. There's a plate put down through there so concrete won't back up into it, but that keeps the fire or smoke from jumping from room to room. That's used a lot in multi-story residentials, motels, condos, things of this nature. Deep decks come in 4.5, 6, and 7.5. They'll span, the 7.5 will span up to 36 feet in a composite situation. They're 1 foot wide for easy handling. These things get heavy when they get real long, so they just stay in 1 foot wide. The ends are crimped automatically at the plant so that you don't have to use pour stop or enclosure, to keep the concrete from flowing back up underneath. They're easier to handle. Your fire ratings, your UL, normal weight, lightweight for the 4.5, 6, and 7.5. We also have it in the acoustical. Again, easy crimping every 12 to 18 inches, attaching the end of the beams. Fast track, where you have the channel frame on the ground, put all of your decking and stuff on the ground together, and just raise it up in the air, and it's one unit. That way you don't have to tie off and work up in the air. Long spans saves a lot of time. A lot of steel comes out of a job when you use this. You can fur out the bottom of the decking, put sheetrock up there. You can't even tell there's metal deck up there. The dovetail decks can have openings cut without having to reinforce them. There's anchors that can be screwed up into the V part, hang lights, speakers, whatever from. The benefit of long span decks, less concrete, clean, fire resistant. This is a case study here. We were able to replace existing wood floors. They used this was a 1883 book bindery. The original flooring was wood and had wood columns. They were going to make luxury apartments out of this. And what happened was that if they went in there with conventional joist from beam to beam, they were going to lose head height. If they went in there with steel beams, the same thing. So what they did is they went in with this long span, deep composite deck, spanned 36 feet from wood beam to wood beam. This is the apartments now. They sell in the millions of dollars, but look at them. They just brought it in with it already down. But one of the things was this was an 1883 book bindery. This was an old building. By using this type deck and it being 1 foot wide, every piece of that deck was taken in through the windows. They didn't take one brick off that building. So they didn't have to replace any of the outside facade of the building. Saved them a lot of time. BIM's a great tool. BIM is one of those tools that I don't think is used enough, but BIM gives us the opportunity to work with the drawings that are provided to us by the architect or engineer. We can do them from scratch, no matter whether you're the electrical, mechanical, joist, steel supplier. Everything goes into the master model. We use Tekla, but Revit is mainly used by the architects and engineers. Different brands, SDS2, but they all speak together through the IFC information transfer. It's electronic. It all goes together. It'll all work together. No matter which format you use. This was a project that was designed in BIM. You can see that the ductwork is running through there. And here he's filed with the web members. This was caught early on. Once you did BIM, once the dimensions were put in, so you were able to offset this. The other side went through there perfectly. All of the proper supports and braces are put in there for weights and loads. This was BIM projects that were done, the tilt-up wall projects. Now you can see the joist and joist girders. And then other than the little men on the scissor lift, looks a whole lot like those BIM drawings. Chapter 5, Frequently Asked Questions. In close, I know we've gone through a lot of material in a very short amount of time today, so we hope that these questions and answers will help clear up some of your questions. We are often asked about the recycled content in steel joist and deck. Well, you may have heard the story about how the mini mill concept revolutionized the steel industry. Our steel is sourced from electric arc furnace mills operated right here in the USA. Every month, millions of tons of scrap steel are processed by the electric arc furnace or mills and mini mills, which is why the steel used in buildings and bridges construction is in the highest recycled content. In fact, steel is the most recycled building material in North America. The life cycle of steel construction is well documented in our industry. Our steel deck is made from scrap steel ranging from around 45% to 57%. Our steel joists can be made out of up to 80% scrap steel. So when you compare how much construction steel ends up in landfills every year, the percentage is very low. A majority of the non-recoverable construction waste is concrete, brick, and clay. We often are asked about the difference between hot-rolled and cold-rolled steel joist and deck. For example, the C-channel that becomes the webbing can be either hot-rolled or they can be cold-rolled. Hot-rolled C-channels are shipped to the joist manufacturer and fabricated directly into the joist. But cold-rolled channels are made on site by the joist manufacturer by slitting cold-formed steel coils. Neither of these methods should be confused with light-gauge cold-formed steel trusses. The design standards for hot-rolled and cold-rolled steel joist were developed by the Steel Joist Institute, or SJI. The SJI requires that all rolled shapes must meet these standards. Another frequently asked question relates to the emergence of ICC ES reports. ICC reports are often associated with new building products coming onto the market. For example, the ICC has begun to collaborate with the Green Building Council to support more innovative green building construction. But you also need to abide by local code requirements, such as Miami-Dade in Florida and LA Research in Los Angeles, California. On the topic of sustainability, noise control is increasingly becoming an issue. Noise is measured in two ways, NRC and STC. NRC is a measure of the amount of sound energy absorbed upon striking a particular surface. An NRC of 0 indicates perfect reflection. An NRC of 100 indicates perfect absorption. The NRC value of acoustical metal deck ranges from around 0.6 NRC for B acoustical deck to 1.0 NRC for dovetail cellular acoustical. So applications for a higher NRC and exposed acoustical deck ceiling can do the job, and without adding an acoustical drop-down ceiling. Noise is also measured by STC. STC is a measure of sound transmission through a wall or ceiling. The goal for most STC applications is to design the wall or ceiling to be at 50 STC or above. Here again, several design variables come into play. We are often asked about coating options for steel joist and decking. One option is to specify the steel is galvanized according to ASTM A653. When galvanizing, the steel is typically given a zinc coating before it is coiled and shipped to the facilities. Galvanized coatings typically range in thicknesses from G30, G60, G90, and G120. The level of protection depends on your application. For example, let's say you're designing a facility to convert seawater to fresh water. A G120 galvanization makes lots of sense. But in addition to galvanizing, you may want to add a paint system for protection and to provide a certain color. In addition to the factory applied galvanizing, you can have the joist and deck company supply the product already protected to any of these levels. For many joist and deck applications, we apply a primer coat in the factory. Then the product is painted in the field. A 3-coat system will provide the longest protection, up to 30 years. But when looking at your most common paint systems, we have several options depending on what your applications are. So let's say you have a 30,000 square foot project. Thinking long term, what coating system brings the best value to the building owner? For some projects, environmental concerns may not be a factor. So we might specify option A, or more conservatively, option B. So we spend around $125,000 for a paint system that will give us 15 years or so. But if we are concerned about moisture, humidity, high UV environments, then we need to think about more protective coating combinations. To avoid an escalation in cost, we've found that the best value will be option C. This has an epoxy primer base, followed by a polyamide epoxy intermediate coat, topped with a polyurethane coating. So we have a 3-coat system that will provide a life cycle for more than 20 years and for less money in the long run. Field applied or factory applied. There are pros and cons either way. Here are 2 stadiums with exposed steel decking. The decking on the left was coated in the field. The decking on the right was coated at the factory. When coatings are applied at the factory, they tend to be more uniform, more safely applied, and there are no VOC issues. These are all factors that contribute to sustainability. If you have an acoustical deck application, this can also be a special concern. We've seen projects where the acoustical performance of the decking has been impaired because the perforation holes in the decking were clogged by spray painting. This has been an educational program. You do get 1 hour's credit, AIA or PDH. Thank you for joining us today. We really appreciate it. If you'd like, we have other courses available online. You can go to newmill.com and look up one of our other courses. Again, thank you all for joining us today.
New Millennium Building Systems. We're building a better steel experience.